Okay, now things are starting. Okay, now on my screen here, let me clear the screen and exit. So now, I think I will better if I delete this. Escape. Let me quit. There's no changes. Okay, now what I want to show you is the difference. Now the header of this, the title of this video is the difference between Rust and C in terms of array. So before anything further, let's get started. As you can see here in Rust program, if we open this program of array, I mean from the source main.rs, now you can see, let's write a simple program here. Let's write a simple program. It's gonna be use std ios because we're gonna use this create here. So I'm gonna create the function. Where should I put it? Okay. So now I'm gonna create a function main as usual. And now in this case, I'm gonna say, okay, let a. So let's put some stuff in the array. Let's a equal to 1, 2, 3, 4. Okay, 3, 4. So now we have 4 items on the array. And the next things here, if you, let's print this. And you're gonna say, please enter an array index. Because what exactly we wanna have is we wanna let the user to put the number, and because we have the size of our array, we want a user to put the number in Rust, put the number when prompted, and if that number, if that because that number is going to be the index, so if that index exists in the array, then the program will output the result and we will see the result. But if the index is out of bound, we don't have that index on the array, then we want the program to panic, because as they say, Rust handle this kind of situation. So now let's see, because we're gonna print it out, but let's create this variable called index, which is immutable, because this variable is gonna be of data type string, and we're gonna do the std input output. So in std in, because we want to read line, so yeah, so the read line, we want to read what user put in there. So I'm gonna say read line, and because our mutable index file is here, and let's handle this error by saying expect. So we're gonna expect if they're gonna be any error by the time of scanning the value. So let's expect to type the failed to read line. So we handle this error. Now when we go back, let's create another when you say let index, because remember we have the file, we have the variable called index, but now we already stated that this is mutable. So when we say let index use size, okay, so now the data type is different, and we use late, remember we use rate to specify now this is something else. So it's going to be the old index which we have, and I think we're going to trim it to clear. We need to trim it now. We're gonna trim it, and we say we're gonna do the parse. So we're gonna pass, and we're gonna expect something, if anything, if the error returns. So we're gonna say index entered was not a number, not a number, like this. Okay, now the thing which we need that element after grabbing the data, after scanning the line. Now we need to grab that, anything which is been there, and we hope it's going to be a number. So we're going to grab that and save it into this variable called element. So element is going to be equals to of course, what we save it is index. Now the element is something else. I'm sorry if I confuse you. So the element now, because the element is something which is like the result after uh, getting the index from the user. Now we need to grab that element from the array if it exists. If it doesn't exist, now we're gonna panic. So now we say let element equals to the array name, which we call the array name A, and we passed in as the way we access the array with the index, so we passed in the index, which is the value the user passed in when he was prompted on the by the program. So now if everything works fine, it's gonna just print it's gonna print that information with this value, the strings, the value of the element at index, and let's specify that index at this index now is, so let's put that element at this index at this, we'll put that element, okay, bravo. Okay, so now we're expecting, well, so what we have in here is we're expecting all this to run smoothly, just like this. All right, so let's save it and let's say cargo run. So we're going to run this program to see if we get any error. Of course, we get an error here, expected semicolon found print line. So I think we need to get back to the program. It seems like we missed semicolon on that number, the first one on the print line. Which semicolon they say it again? On the let, yeah, so we miss here. So I think we're just gonna say, okay, we missed here, let's light it down, let's save it. So now cargo, let me clear the screen and say cargo run. All right, now it's compiling and give me the warning, because by the time I'm creating this binary folder, which is like a package, I put it like a camel case, and I was supposed to put like a snake case, you know. So in this case now, let's please enter an array number. So now we remember that in our array we created, we have 4 values, 1, 2, 3, and 4. Expecting that we're gonna have array index number 0, 1, 2, and 3. So now if let me try to put the number between those, let's say 2. So for 2, I'm expecting to get 3. So if I hit enter, now say the value of the element at index 2 is 3, which is work perfectly fine. So now what happened if we put a number which is not on the index, which is not on the list now, which is like, let's say 9. If we hit there, now the program panics. Say thread main panicked at index out of a bound, the length is 4 but the index is 9. So the program actually panics. Alright, now what happened if we put number beyond, like the number is too big? Is it gonna return the same? So let's say 1,000 by this case, something which is out of the segment. All right, it's still panic. It's still panic because they say the index which you assigned is not on the list. Now, in this case, let's create another project using C program. So I think I'm gonna go back here and I have this folder called ceiling. I'm gonna cd to ceiling. Now in this case, let's write this program called hello.c. Alright, so we're gonna write this program called hello.c. Alright, so I do remember using C, we can write include, write this stdio as usual. So stdio.h like a header, and we're gonna have the int main. Alright, int main. Now we're gonna say int y, put a semicolon. This is just like a variable. Now the int y is going to be something which is passed in, by the user. So we're gonna say, okay, now print to prompt the user. So we're gonna write like information, which is printf. So printf, let's say type a index, type a number index. Let me say type a number. So type a number. So now we expect for user to type the number, and if that's okay, and we expect that number, if that input to be a number, and we're gonna hold it using D, as you know, the data type for a number. And so we're gonna store that variable to this y, okay, in the number. We're gonna store that variable to int y, and then after that I'm gonna say now we have the integer. So now I'm creating the array. So let's say my array size is gonna be equals to 3. All right, we're creating the array. Array size is gonna be 3. Now equals to, let's write those numbers. Say 1, let's 2, let's say 3. These are 3 elements, which is great. Now we're gonna print. I'm saying, okay, now your result, the value of the element the value of the index provided is so now the value of index provided is this one. So as you know, we're gonna pass in like this, as it's gonna be a y list, simply as that. So now in this case, let's try to run the program. By using GCC as the compiler, the C compiler. So I'm gonna say GCC hello.c. I'm expecting to get a binary, and if I'm gonna ls here, and you will see the binary, which is output.out. So we can simply run that program using this program. So now type a number. Let's type 2. So in this case, we will getting 2. Okay. Now we got 3. I'm sorry, we got 3. Now if I try to rerun the program and type, let's say 9, the number not in the index, it say now the value of the index provided is, so still it's gonna read, but it's gonna provide me with different numbers, which is really weird. This is not what we expect. And so now let's try to put number which is greater than this. Let's say 1,000. Okay, let's say 1,000. Now we get the segmentation fault, because even the array provided on that, the memory chunk, even the value which we provide is not even on the memory chunk. It's something out there. It's out of the segment. Now remember, we get different values. That's why here they said this is an example of the raster memory safety principle in action. In many low-level languages, this is a kind of a check which is not done. So when you provide an incorrect index, an invalid memory can be accessed. Okay, as we know, we access using C. Now Rust protects you against this kind of error by immediately exiting instead of allowing the memory access and continue. So we prove like Rust is very good. It helps us in memory safety, especially when checking something which is when you provide an incorrect index. So thank you for listening to this video. I hope you like, and if there is anything you need to add up, make sure you write down on the comment section below.